What if I told you that the biggest cosmic event in our galaxy's history has just begun? The Andromeda Milky Way merger is happening right now, and it's going to change everything we know about the universe. Curious to find out how? So let's get started. The collision between our Milky Way and the Andromeda Galaxy has long been predicted by astronomers. It has been confirmed by recent observations that the merger began earlier than predicted. This fragile, almost undetectable halo of diffuse plasma extends as far as 2 million light-years in certain directions and 1.3 million light-years from the galaxy startled scientists. It is located roughly halfway to our Milky Way. This indicates that our galaxy's halo is already merging with Andromeda's halo. Additionally, they discovered that the halo is composed of two primary, unique, nested shells of gas. The halo around a galaxy has never been studied thus thoroughly. Did you know that the Andromeda Galaxy, also known as M31, it is a colossal spiral containing up to 1 trillion stars, much like our Milky Way. At 2.5 million light-years away, it appears as a cigar-shaped smudge of light in the autumn sky. Can you imagine its gaseous halo, stretching 3 times the width of the Big Dipper, making it the largest feature in our nighttime sky? Andromeda is the only galaxy in the universe that can be studied with Hubble, and only with an ultraviolet-sensitive future space telescope will scientists be able to conduct such experiments beyond the local group. The universe's expansion causes galaxies to move away from each other, but Andromeda is moving towards the Milky Way due to a stronger gravitational pull. This expansion is most noticeable over vast distances, spanning tens of megaparsecs and beyond. Despite the overall expansion, Andromeda and the Milky Way are on a collision course. Collisions on a cosmic scale are different from Earth-like collisions, which happen instantly or in specific moments. Galactic collisions, on the other hand, are slow and dramatic processes that unfold over hundreds of millions of years. For example, the antennae galaxies in the constellation Corvus have been merging for at least 100 million years, creating spectacular star tails due to tidal forces. This demonstrates that galactic collisions are not sudden, but unfold over hundreds of millions of years. The Milky Way galaxy has a rich history of interactions and mergers with other galaxies, significantly shaping its current structure and composition. A recent study led by astronomers has catalogued multiple mergers involving the Milky Way. This research identified a total of 6 significant mergers, including one previously unknown merger named Pontus. These findings were made possible by analyzing data from the European Space Agency's Gaia mission, which has mapped the positions and motions of billions of stars in the Milky Way. Another type of star can be observed. Hypervelocity stars, HVSs, are among the fastest objects in the galaxy, exhibiting a unique ability to escape the gravitational grip of their own galaxies. These stars, like cosmic splinters, can travel at speeds of around 1,000 kilometers per second, allowing them to travel around the entire planet in just over 40 seconds. One main scenario for these stars to attain such high velocities is an interaction with a galaxy's supermassive black hole. Imagine a binary star system where 2 stars orbit each other in harmony. When the black hole's intense gravity disrupts the binary system, one star is captured and the other is slingshotted away at incredible speeds, leaving the galaxy. This ejected star becomes a hypervelocity star. Alternative theories suggest that a star can also be expelled from a binary system due to a supernova or interactions between galaxies. In 2005, the first hypervelocity star was discovered by astronomers using the Multiple Mirror Telescope in Arizona. The star is 71 kiloparsecs from the Sun and moves at 850 kilometers per second, 528 miles per second, through the galactic halo. It is expected to leave the galaxy within 80 to 100 million years. Astronomers estimate that a star is thrown from the galactic center every 100,000 years, with about 1,000 hypervelocity stars heading out of the galaxy. By measuring their movements across the sky, it is possible to refine our knowledge of the Milky Way's shape and distribution of dark matter. Two scenarios were used in the study to assess the trajectories of hypervelocity stars from the Andromeda galaxy: equal mass and half mass. The equal mass scenario demonstrated that increased gravitational interactions between the two galaxies may allow a small fraction of stars to reach the Milky Way's vicinity. A tiny percentage of stars might move to the Milky Way, according to the half-mass scenario, which made the assumption that the Milky Way had around half the mass of Andromeda. To ensure a realistic and broad range of possibilities, the scientists started the stars at random points around the core of Andromeda and gave them random directions. They then used both mass scenarios to analyze the speeds of the hypervelocity stars as they approached the Milky Way. They found that a tiny fraction of these stars were able to reach the Milky Way's vicinity. The stars in all scenarios are distributed nearly equally according to a sky map that displays the locations of the hypervelocity stars around the Milky Way's core. Because of the stronger gravitational attraction between the two galaxies, there are a few extra stars in the scenario where the Milky Way has the same mass as the galaxy from which they originate. Additionally, the researchers compared the positions of these artificial stars to real data from the Gaia spacecraft, providing more evidence in favor of the theory that Andromeda's hypervelocity stars have really moved into the Milky Way. According to a study, there could be anywhere between 12 and 3,910 hypervelocity stars in the Milky Way from Andromeda. This implies that star migration across galaxies is a genuine and quantifiable phenomenon, suggesting that star exchange between the Milky Way and Andromeda has already started. The second piece of evidence is found in the two galaxies' halos, which are vast gaseous webs that encircle and surround their star-forming spirals. By analyzing the light from 43 quasars located behind the Andromeda galaxy, astronomers were able to map the galaxy's halo. Andromeda's halo is larger than previously thought, extending 1.3 million light-years in our direction and 2 million light-years in other directions, according to data from the Hubble Space Telescope. Given that Andromeda is approximately 2.7 million light-years from Earth, its halo almost approaches the Milky Way, suggesting that the two galaxies' halos are already colliding and that the epic collision has already started. If this plot twist about the Andromeda Milky Way merger blew your mind, don't forget to like this video and subscribe to our channel for more cosmic updates. What are your thoughts on this galactic event? Drop your comments and questions below. We love hearing from you. Stay tuned.